Hello, my name's Keith. I'm the author of Chibi Akumas, which is an Amstrad CPC game which I'm currently porting to the ZX Spectrum and the MSX2. Now today I'm going to talk you through the development software I'm using. The software I'm using is all open source, it's all free software. Sorry, I lied there, it's not all open source, it is all free software. Some of the software, I've written a few small tools myself, and I've written some scripts which are helping me with the development and building the software, building my game. So we'll have a look today, and I'll show you how it works. And maybe you'll be interested. Maybe you want to try some of it yourself. Maybe you'll learn something you think you can use. I hope so. Anyway, so you'll see I've got this Z drive here. Now this is a virtual drive. I'll show you how that works. I create it with this batch file. And all it does is it uses the Windows DOS subst command. That takes a folder on your system and it gives you the drive letter. The reason I do this is because if I want to copy the development system to another machine, then anything that's using a physical path will map to the Z drive, and wherever it maybe will end up on an SD card and on a tablet, but as long as that Z drive still exists, which it will because of the substitution, then the system should hopefully work the same. So that's why I'm using that Z drive here. And you'll see I've got a variety of batch files here, some shortcuts to some programs, and we'll go through them one by one. Now the first one is the backup batch file. Pretty self-explanatory. All it does is it uses the 7-zip command line tool, and it creates a backup of all of the files, excluding the emulator files because they're quite large. So this is my source code, my sprites, disk images, whatever. I do backups regularly. That way, if I make a mistake, then I can revert to a previous working version, which happens from time to time. And the backups have saved my neck on occasion. So yes, backup off, and that's what that script does. We've got the link to the CPC emulator, which is WinApe. We'll have a look at that later. We've got a script here that this recreates the disk image. It updates all the files on the disk image for the MSX system. Now I'm using OpenMSX as my MSX emulator, and it uses disk image emulation. However, it doesn't use a disk image. It uses a folder, and it treats that folder as a disk image. So just something to bear in mind there. So anyway, this script updates the files, compressing them where required, and also it will give them the correct file name. So let's have a quick look inside. And all it does is it goes through each file. For example, the loading screen file. The source file is loadingscreen.rle, and on the disk it needs to have this name. And then it runs the command add one, which adds one file to the disk image. You may see further down, here we go, the title file is actually compressed. So it uses add1z, which runs our compression program. Now Z isn't zip, Z is LZ48, which is a command line compression tool which the author Rududu created, and it's absolutely superb. Now the compression is done by a Windows command line tool. The decompression is done within the Z80 assembly. So anyway, you'll see that the files are added there, and we've also got another tool called MSX Header. Now this is a small program I wrote myself. MSX Spectrum Plus 3 and Amstrad disks all need a header attaching to them for the DOS systems to easily open them. So we'll have a look at the tool, wrong folder, so we'll have a look at the utilities that we've got here, and we'll see some of them now. So the first one is 7-zip. It's only used by the backup tool. Bin-tap is a command to convert a binary file to a tape chunk for the Spectrum tape system. CPC Disk XP is the Amstrad CPC tool, although I'm actually using it for the ZX Spectrum Plus 3. Because Amstrad made the Plus 3, the disk images are the same, however the headers do need to be different. You can't attach an Amstrad CPC disk file with an Amstrad CPC created file on it and open that on the Spectrum even in binary format. The header is different, unfortunately, which is why I created my own tool, which we can see just below. LZ48, as I mentioned, is Rududu's compressor. Absolutely brilliant. And make-tap is a file for creating tape files. Again, ZX Spectrum. MSX Header is a little program I wrote, which attaches a valid MSX header so that MSX DOS or BDOS can open the file okay. So it doesn't really do much, just adds a sort of magic number and a file length basically. +3 header is very similar to the Amstrad CPC header. The Spectrum requires a 100, I think it's 128 byte header with a few keywords, the length of the file, and a CRC check as well, and that just creates that. And then a sleep command, which just is a pause command for batch files, and then TRD tool, which is a very fine tool, which is basically CPC disk XP for TRD files. Now TRD is a Spectrum disk format which is quite popular, it's a bit tricky to work with, not because there's anything wrong with it, but just because the documentation tends to be in Russian. TRD tool is the best tool I've found to work with them. It's also pretty much the only tool I've found to work with them, so I'm very glad for it because it's really doing a great job. So anyway, that was a quick look at the tools. So we'll carry on now looking at the batch files. We've had a quick look at MSX Akugo. Next we've got Catapult, which is the launcher for the Open MSX emulator. So we'll have a look at that again later. MSX Debug is the debugger for Open MSX. The two are actually separate programs, but they kind of link together in memory and works fine. Very good. Work timers, it's just a stopwatch I use to make a note of how long I've been working on each system. Z drive is the subcommand we've already mentioned. ZX Akugo, this is the sort of main script for building the Spectrum files. Now I'm developing for 3 different disk systems for the Spectrum. DSK is the +3 disk system. TAP is actually a tape system for compatibility. Unfortunately, I'm having to do TAP. And TRD is the Russian format, which is also called Beta Disk. It's fine. It seems to work quite well. It took a bit of work to get going, but once you get it going, it seems to be very good. Nothing wrong with it. So anyway, the reason you've got these sort of 3 batch files here and then this file here actually does all of the work of adding the files, and these are just an init command. Just ignore the bottom chunk of this. It's just these 4 lines at the top that do the work. The rest is just old code I've not deleted. The exit command is the last command that's executed, so the rest is ignored. So the first line defines what the disk file is. The second line defines the script that's going to be used. So if we have a look at this one as a comparison, I've actually cleaned that one up. So you'll see this one uses the tap command, this one uses the DSK command, and then they all just end up running ZX Akugo, and the TRD ones are exactly the same. So let's have a look at ZX Akugo and we'll see what that does. So we start off, and you'll see what it does is it ends up running running these commands with the label attached to the end. And then at the bottom you'll see there's multiple versions of the commands for the various systems. What they do is they add the files, they compress them if needed. If add one just adds the file, add one Z adds the file and compresses it. And then once all the files are added, the emulator is started, and you'll see the emulator is executed with a few command switches for the correct machine, either +3 or 128, and with the disk image. And also I use a snapshot, which is a memory snapshot, and what this does is actually loads the emulator ready to start the game. We'll just show you that actually, no reason why not. So we'll just run ZX Akugo disk, which is the +3 version. You saw the script run in the background, which was updating the disk image. Now the memory snapshot starts with this position, which is the basic command about to run. The reason I do that is this gives me a quick chance to add in some debugger commands if I need to. We'll have a look at the debugger. The Fuse debugger, the Fuse emulator is superb. Unfortunately, however, the Fuse debugger is a little bit basic. So we have a look at it here. By which I mean I'm right clicking here, it doesn't do anything. I'm not aware of any skip over breakpoint shortcuts on the keyboard, which Open MSX and WinApe have, but this one doesn't. Everything has to be done from the command line. So if I want to break at 50, I do BR $50. And then if I want to get rid of that, I can't right click on it. Right clicking does nothing. So I have to do CL $50, and I just mistyped, so it doesn't do anything. Which this is kind of the problem. The one that drives me nuts is if I do BR and 0050, which is the way you do a hexadecimal symbol in WinApe. It comes up with an error, which you can't see because it's off your screen. I apologise. But then it adds a breakpoint at the current point, and then I need to clear that. So, yes, I don't wish to slur Fuse too much because, as I say, it's free. What can you expect? But yes, the debugger is a slight I'm really having trouble now, you see. Yes, this is just proving my point. So CL038. If Fuse had the debugger of WinApe or OpenMSX, it would be flawless. The emulator is absolutely superb. The debugger is making my life unfortunately a little bit harder, but as I say, it's the best I've found that's free, and the emulator is excellent, so I'm putting up with the debugger. Anyway, sorry about that little complaint there. So let's just load the emulator up and we'll see the thing running. Now I can increase the speed just so we don't wait around all day. And you'll actually see, you'll probably be a bit surprised, but you'll actually see the game will start, and it will start with you run out of lives. The reason for that is it's a modified build. Rather than starting at the main menu, it jumps straight into a level so that I can test the level quickly. But the game code gets confused because the game started, but the player's got no lives because it hasn't gone through the proper procedure. So that's why that happened. It's not a problem, it's not a bug, it's just that's what happens when you modify the code to jump into the game at a sort of artificial point to speed up the testing. But anyway, that's the disk version. The TAP version and the TRD version load up Fuse exactly the same. All that's different is the script works slightly differently with regard to building the disk images. And then you've got these three here at the bottom, which are exactly the same really in function. All they do is, instead of loading the game, they run a small program called spectest.bin. That's something I used in my development so that I could, if I needed to test a small piece of code, or if I needed to do something like test my RLE decoder and show an image on screen, rather than hacking that into the main game core, I just created it as a separate program, got it working with those scripts. Once I was happy it was working, integrate it into the main game. So that's all they are, nothing very important there. And so we'll have a look at OpenMSX then properly. So as I say, if I've changed any files that need to be updated on the disk, I use this script, but if I haven't, then I just use catapult and start, and the emulator will start. Now, one tricky thing I found with OpenMSX is if you change the files, it's using this folder as a disk image, which works great. The only tricky thing is if you change the files in that folder, OpenMSX doesn't notice until you stop and restart the emulator. So if I've updated, say, the level 1 file, I just click stop and start, and then there's a nice trick. You want to make sure you're using an emulator that doesn't have the firmware. So the Panasonic A1F isn't a great choice because that has built-in firmware. And then you can just press F9 and it runs at super high speed and it starts loading the game a bit quicker. The MSX version is quite slow just because there's so much data being loaded, but as I say, you saw that it is now running at fast forward, so the game will start a bit faster. No splash screen, it's turned off. It is finished, it's just I'm turning things off that aren't needed for testing. Any seconds I can scrape off the load time during development is, if I'm running it 50 times in a day to try and fix a problem, then a few seconds of loading the splash screen is well saved. So yeah, the game's just loading now, and while it is loading, I suppose we might as well load the debugger. The debugger is a separate program, as I mentioned, and all you do is you click the connect button, and it connects to the emulator. And so here's the MSX version. That's enough of that. So anyway, yeah, as I said, the MSX debugger is very good. It has really all the functions. It's got shortcuts here, so you can operate it from the keyboard. You can edit variables and things, edit registers in memory. Yeah, superb. Really, no complaints at all. OpenMSX, very, very good. Nothing really more I could want from it. The only thing WinApe has that OpenMSX doesn't is a built-in assembler. which is what we'll come to now. So I'm using WinApe, which we'll just get onto screen here, just a second. So here's WinApe, and here's a WinApe assembler, and this is kind of my my dirty secret with regards to the game's development. This will probably cause horror and dread in the minds of the Spectrum and MSX users. I'm actually using the Amstrad CPC assembler in WinApe to develop the Spectrum and MSX versions. I will explain why that is. There's a sort of good reason for it. I was looking for a free assembler for my development, struggling to find one that I could work particularly easily with. The reason being, I was quite happy with WinApe in general. It's got a built-in editor, it's got an assembler, they seem to work very nicely, so no complaints there. Some of the, I suppose you could argue that WinApe is too unrestrictive compared to other assemblers, but a lot of the commands I was using weren't working with the other assemblers. Things like needing tabs at the start of lines, labels needing certain definitions. For example, I'll find one where I'm using self-modifying code. For example, I'm putting a label at the end of the line. WinApe's quite happy with that. I'm quite happy with that. Other emulators look at it and go, "What the hell are you playing at?" They don't like it at all, which is fair enough. But I've got rather a lot of them. So when it came to working out how long it was going to take to convert the game to other systems, using a different assembler was going to be a serious problem. And at some point I suddenly realised, well, hang on a minute, it's ASM code. It doesn't really matter what it's developed, if it doesn't develop with, as long as it runs. So even if I'm developing with WinApe, WinApe's got loads of great save options. What difference does it make? And the answer is absolutely none. So let's have a look. So you'll see at the top of the files, we've got these three commands here. All I do is I rem out two of them and unrem one of them. So if I'm developing this MSX, if I'm building the MSX version, I enable that one. If I'm building the CPC or ZX Spectrum one, that one of the other two. Now I'll explain just briefly at this point. The core, which is the game engine, is compiled for multiple different systems. There's two versions for the MSX, depending on whether the user has a V9990 graphics card attached. There's three versions for the Spectrum, one for the DSK system, one for the TAP system, and one for the TRD system. And there's currently just one for the Amstrad CPC. The Amstrad CPC version is more complex. It handles the 64K to the +3 to the CPC Plus, sorry, 128K. All in the same version, which means it's quite large, but that's the way it ended up. But anyway, the point is the levels are only compiled for the hardware platform. The level doesn't care whether it's on a V990 or not. It doesn't know. It doesn't get to choose. That was because I didn't want to compile, 5 different versions of the level for all the different hardware platforms. So there's only 3 versions. So anyway. And if we have a look here, you'll see here's the command that saves the Spectrum version, and it writes it to a binary file, and then those batch files I showed you earlier will actually attach the appropriate headers and put it into a disk system. Now the MSX, because I'm only working with one disk system, I write it straight there, and you'll see these commands here actually just create the valid header for the MSX version, so I don't need to use any command at all to add a header. It's done already there. And I should point out at this point, WinApe's assembler is so good, it can actually create a valid Spectrum header as well for the +3 system. The +3 requires a 128-byte header, the length of the file, and a CRC bit, a CRC check byte. But WinApe can do it all. The only reason I'm not doing it here is because I wanted to compile a single file and add it to all 3 disk systems. So I'm using my external tools and the batch files to do that. It's not because WinApe couldn't do it itself, it could. Now the Amstrad CPC save command is right at the bottom here. So as I say, one piece of code here. It compiles for 3 different systems, compiles for, on the Spectrum, 3 different disk systems. It works absolutely great. Bit odd using WinApe as an assembler for all 3 systems, but it's working great for me. And as WinApe, while it's not open source, it is free. So what more could I want? Well, absolutely nothing really. So we'll just, for completion, let's start the game on the old Amstrad CPC. Apologise, working so many systems, I'm getting them mixed up. And so let's start the game. Trying to remember what what controls I've got set up for this one. So here's the updated boss for the old Amstrad CPC Plus. This is the version 1.666 that I'm developing now. You'll see the backgrounds have been improved. We've got some mountains and some little bones in the background, and also you'll hopefully notice that we're now using CPC Plus colours. We've got a nice sort of tan coloured bone effect rather than the old sort of black and white, which maybe makes it look a little bit nicer, and hopefully some more colours in the background. Apart from that, everything's pretty much the same. Well, anyway, that's about it for today. I was only looking to give you a brief introduction. I'll maybe do another follow-on video with some more detail. If anyone wants more detail, anyone wants specific information on something else, please let me know. I'm going to do some more videos, probably on my Patreon system, explaining the details of how the level code works and things like that. Hopefully, if you're interested, you'll follow me for those. Thanks a lot. Take care now.